Welcome to Brain Vision.
Hey guys, let's do problem 92. The first problem says why the tank is purged. Now the tank is being purged to remove oxygen. Oxygen is a component in hydrocarbon combustion. So oxygen is the necessary component of hydrocarbon combustion. So the tank is purged to remove oxygen. So there, when the fluid is added, there is lower chance of ignition. Okay, then the next problem B, it says to calculate the gauge pressure and mass of nitrogen. The molar mass of air originally in the tank is the moles of air original in the tank is PV divided by RT. Let's sense out all these known values. Pressure on atmospheric pressure, it is 5000 liter volume. The temperature is 298 Kelvin. Therefore, the moles of air originally in the tank is 204.3 moles. We know air contains 21% of oxygen. Therefore, moles of oxygen is 0.21 multiplied by number of moles of air, or number of moles of oxygen is 42.9 mole. Therefore, the total moles of gas in the tank after adding the nitrogen is number of moles of gas equal to number of moles of oxygen divided by 10 multiplied by 10 to the power 6. From here we get 4.29 multiplied by 10 to the power 6 mole as the total moles of gas in the tank after nitrogen is added. Then the pressure of the gas is equal to in gas, number of moles of gas multiplied by RT divided by the volume. The number of moles of gas is 4.29 multiplied by 10 to the power 6 mole. Temperature is 298 Kelvin. The volume is 5000 liter. Therefore, the pressure of the gas is 2.1 multiplied by 10 to the power 4 atmospheric pressure. And the mass of nitrogen used. Mass of nitrogen used it is the total moles of gas minus air originally in the tank. Therefore, total moles of gas minus the number of moles of air in the tank multiplied by the molar mass of nitrogen. Therefore, the number of moles of gas is 4.29 multiplied by 10 to the power 6 minus 204.3 mole multiplied by the molar mass of nitrogen, which is 28.02 multiplied by 10 inverse 3 kg per mole. Therefore, we get the mass of nitrogen is 1.2 multiplied by 10 to the power 5 kg. Now we need to calculate the number of charge vent cycle and mass of nitrogen again. Let's do that. Problem C. We know that the critical temperature and critical pressure for nitrogen is 33.5 atmospheric pressure. Critical temperature is 126.2 Kelvin. Therefore, we can calculate the reduced temperature and reduced pressure. The reduced pressure is the given pressure divided by the critical pressure. The given pressure is 700 kilopascal gauge pressure. Let's convert it to atmospheric pressure and then to absolute pressure by adding 1 atm. Therefore, 700 kilopascal multiplied by 1 atmospheric pressure. Let's convert it to this atmospheric pressure by dividing it by 101.325 kilopascal. And we need to add 1 atmospheric pressure to convert it to absolute pressure divided by the critical pressure, which is 33.5 atmospheric pressure, and this calculation gives reduced pressure of 0.236. Similarly, for reduced temperature, the given temperature divided by the critical temperature. Given temperature is 298 Kelvin and the critical temperature 126.2 Kelvin. Therefore, the reduced temperature is 2.363. Now for this reduced pressure and reduced temperature, we get the Z factor. We get the Z value as 0.99. Now we can use the compressibility factor equation of a state and calculate the number of moles of gas. The number of moles of gas in fully charged tank is then and number of moles of gas equal to PV divided by CRT. Pressure is, again let's convert it to atmospheric pressure, 700 kilopascal. 700 divided by 101.325 atmospheric pressure plus 1 atmospheric pressure multiplied by 5000 liter divided by Z factor 0.99. temperature 298. Therefore the number of moles of gas we get is 1632 mole. Okay, therefore we can calculate the mole fraction of oxygen. Now the mole fraction of oxygen after the first discharge when the pressure is equal when the number of moles is equal to the original moles in the tank at the atmospheric pressure. Therefore mole fraction of oxygen after first charging where number of moles is equal to the original moles in the tank. Therefore the number of moles is equal to 204.3 mole. Now we can calculate the mole fraction after first charging. It is equal to number of mole fraction of oxygen in the air, which is 0.21, multiplied by number of moles of oxygen during the first charging divided by the number of moles of gas. Therefore 0.21 multiplied by 204.3 moles divided by 1632 mole. Therefore the mole fraction is 0.0263, and the mole fraction of oxygen at any n charges can then be written as at any n charges xO to n is equal to the mole fraction of the mole percentage at the air multiplied by the number of moles divided by number of moles of gas to the power n. Now we can solve for n when this equation is equal to 10 ppm. Let's do that. Therefore ln 10 multiplied by 10 inverse 6 divided by 0.21 equal to ln n divided by number of moles of gas to the power n. Let's solve this equation. Therefore number of moles n is equal to 10 multiplied by 10 inverse 6 divided by 0.21 divided by ln number of moles of gas divided by number of moles of oxygen divided by number of moles of gas. Let's insert these values again. The number of moles is 204.3 mole divided by 1632 mole, and as we do this calculation we will get 4.79. So at least 5 stages are needed. Now let's calculate the mass of nitrogen. Here the mass of nitrogen used would be the moles of gas in the tank at full pressure minus the original moles multiplied by the molar mass and the number of charges. Therefore, the mass of nitrogen equal to number of moles of gas minus number of moles of air multiplied by molar mass multiplied by the number of cycle. Let's insert all these values. Molar mass of nitrogen is 28.02 multiplied by 10 inverse 3 kg per mole, and the number of cycle is 5. Therefore, the mass of nitrogen is 200 kg. And finally, we need to explain what is the advantages and disadvantages of multiple cycles. The advantage of using multiple cycle is less nitrogen is used. Using multiple cycles uses less nitrogen and lowers the maximum pressure the tank could see. But the disadvantage is it could take longer to remove the oxygen through multiple cycles.